And in particular, what I have found over the years is that if you can read it correctly, you're more likely to be able to do it correctly. So anytime we're talking about two things and we're like comparing them and one of them is larger than the other, we can think about that as an inequality. So I'm just going to do some like super easy stuff with actual numbers to start off with. So if I put a 5 and a 7 here, could you fill in the notation for the inequality that goes between the 5 and the 7? And if it's been a minute and you're going, yeah, I know it's either this way or this way, but there are lots of different ways to remember this. Sometimes in elementary school, they talk about alligators like eating the bigger number. Kind of silly, but you know, sure, if it helps. I don't have a great answer to this other than, for me, I think about it as actually that if I think about this as like an opening, there's the bigger opening on the side of the bigger number, and there's basically no opening on the side of the smaller number. So here's the thing. In English, we tend to read from left to right, but I can read this inequality either direction as long as I change the words that I'm saying. So if I were to read this inequality from left to right, I would read this as 5 is less than 7. And if I were reading it from right to left, I would read this as 7 is more than 5, or I could say 7 is greater than 5. If I wrote something like that, and I would read that from left to right, I would read this as saying X is greater than or equal to -4. But I could also read it from right to left and read that as -4 is less than or equal to X. Now the second one, I want to talk for a minute about like other ways that we can express the same thing. So this is basically saying X is going to take on the value of some number, and that number is greater than or equal to -4. I chose a negative number for a reason, but I'm going to think about this graphed on a number line. I don't always put 0 on my number line, but I do think for now it's sometimes helpful to have a 0 on my number line. Since I'm looking for -4, I know that's to the left of 0. So if I put a -4 over here, then this is saying that X could be any number as long as it's greater than or equal to -4. So which direction on the number line should I be shading in? To the right or to the left? Like which half of it captures what I'm looking for? Oh, I think I see some people pointing pencils. I'll take it. So I'm looking for this part over here. Notation wise, if we're talking about a number line, because this has the or equal to symbol, I can show the or equal to part either by doing a filled in circle on the number line, or as another option, I can draw my number line with a square bracket on the -4. Both of those are fine. But if the problem asks you to sketch the solution on a number line, this is what we're looking for. Since we're talking about notation, just for a second, I will also include the calculus-y notation that you're going to need and the notation that you'll probably start using in pre-calc. But if I had x is greater than or equal to -4, one of the reasons that we put square brackets on the number line is that corresponds to the alternate notation for this. So if I think about that number line with the -4 and I put the square brackets on, at either end of my number line, I have like a -infinity and a +infinity. So if I want to show that I want this portion in here, I can write that in what we call interval notation. Pick another color. And in interval notation, that solution would look like -4 to +infinity, because I'm indicating the interval of the number line where all of the answers live. If I'm solving something with an inequality, I'm basically going to treat that as if it had an equal sign. Meaning, I'm going to try to, if I need to, I'm going to combine like terms. I'm going to collect all of my variables on one side of the equation. I'm going to get all my numbers on the other side of the equation. And that's really what we're looking for. So here, I'm going to try to isolate that 3x piece. I'm going to go ahead and add 2 to both sides. So, sorry, I don't want to switch up colors yet. So if I add 2 to both sides, then I'm looking at 3x is greater than 19. And I can either multiply by 1/3 or divide both sides by 3, whatever feels more comfortable to you. So I'm going to say x is greater than 19/3. For completeness to answer the question, because I asked us to graph this on a number line, when I go to graph this on a number line, good news, I didn't put a whole bunch of little tick marks on my number line, and I recommend that you don't either. If you put a bunch of little tick marks on the number line, then I'm going to expect to see 19/3 correctly between 2 integer values of those tick marks. If you don't put any on there, you're just right. So, and that's going to go, especially when we head into the next chapter, chapter 3, which is all about graphing. Either do it on graph paper, or if you're not doing it on graph paper, just call that 19/3 and be done with it. Okay. This says that x is greater than 19/3. It doesn't have the little or equal to line underneath it. So I can do this with an open circle. And again, because x is greater than 19/3, I'm looking for the part to the right. I've only got x's on the left-hand side, so I'm just going to leave them there. So I'd start by subtracting 1 from both sides. And if I do that, I'll end up with -4x is less than 12. And then I'd have to multiply both sides by -1/4 or divide by -4. I promise not to make you talk, but from a previous life, how many people think there was some rule about negatives with inequalities? Cool. Some people get taught some rule about negatives with inequalities. I'm gonna pause for a second, solve this the other way, and then we'll come back to talk about what that rule is. I look at this and I say, you know what? I'm just going to put that 4x somewhere that it's going to be positive, because I don't want to mess up with signs in a problem. So I'm going to add 4x to both sides right now, which is going to leave me with 1 is less than 13 plus 4x. And now I'm going to subtract 12 from both sides, 13 from both sides, which is going to leave me with negative 12 is less than 4x. Which means my final answer is going to look like, if I divide both sides by 4, negative 3 is less than x. Or, reading from right to left, x is greater than negative 3. Now, if we had gone down this path and I divided both sides by negative 4 right now, we would have ended up with the wrong answer. So, the rule to make sure that that doesn't happen is that if we multiply both sides or divide both sides, the inequality symbol needs to flip. You can often avoid it just by doing what I did and moving the x's to the side that makes them positive. So if you don't want to have to remember more things for now, I would recommend gathering your x's on whichever side makes it positive. So if I finish this off, if I multiply both sides by negative 1/4 or divide by 4, this is going to turn into x is greater than negative 3. And if you're following along in the textbook, the book has this little like symbol-y thing that it tries to use to tell you that the symbol flipped. 2x minus 5 times the quantity 1 minus x is less than or equal to x times the quantity 2 squared plus 4. I know I ramped that up a ton. I know it's Monday morning. How are people feeling? Do you want to try this on your own? Do you want to watch me do it? Where are we at? How many people would like to watch me do it? I got a bunch of head nods. You got it. It's Monday morning. I got all of our energy for us. Okay. I got parentheses, so I want to go back to thinking about PEMDAS. Gotta combine what I can in parentheses first. So here I've got a 1 and a negative x. Can't do much with that. Moving on to these. Great. I have stuff in parentheses and I need to deal with the exponents first. So this is going to look like x times 2 squared is 4. So I'm going to have 4 plus 4, which is 8. On the left-hand side, I'm going to go ahead and distribute through this 5, but because it's negative, I'm going to choose to rewrite this as plus a negative 5. So that the thing that I'm distributing in is the negative 5. So I've got 2x plus negative 5 times 1. So that's plus a negative 5. plus -5 times -x is going to make that a positive 5x. Combining like terms, I know that I can combine the 2x and the 5x. So I've got 7x. I still have that plus a -5, or if you like, minus a 5 works also. It's less than or equal to 8x. So at this point, I'm going to choose to collect all of my x's on whichever side means they're going to end up positive. I've got more x's on the right-hand side, so that's where I'm going to put them. I'm going to subtract 7x from both sides. And I've got -5 is less than or equal to x. So we've got a fraction. I don't have an equal sign, but I do have an inequality. It's kind of the next best thing to an equal sign. I definitely can make the choice to multiply through by 7 right now and eliminate my fractions. But I'm going to pause and think for a second, can I make the number smaller instead? So if I think about that 3/7 in relation to what I've got in parentheses, 7 is divisible by 7, and so is 21. So if I just go ahead and distribute it out, I'm not going to have fractions anyway. So that's going to be my faster path through to keep my numbers smaller, because otherwise I have to figure out what 7 times 25 is, and I just don't want to. So I'm going to take following PEMDAS, I'm looking at parentheses, nothing I can do. I do have exponents over here, so I'll handle those exponents, say that's a 25. And then over here, I'm going to take that 3/7 and distribute it into both parts. You can write more out if you want to, but when I take the 3/7 and I multiply by 7x, no, I'll go ahead and write it out. So I'll have 3 times 7 times x over 7. And when I distribute to the 21, I'll have 3 times 21 over 7. So here my 7 over 7 is a 1. And 21 divided by 7, that should be 3. So I'm going to have 3x minus 3 times 3 is less than x plus 25. And I will let you go ahead and finish it off from there. I'm going to choose to put my x's on the left-hand side this time, because I want them on the side where they're going to be positive. So I've got 3 times 3 is 9. So I've got 3x minus 9 is less than x plus 25. So I can subtract x from both sides. I'll be left with a 2x over here. And if I add 9 to both sides, 9 plus 24, I'm sorry, 9 plus 25 should be 34. So I would have x is less than 34 over 2. It's okay for you to leave 34 over 2 alone, but 34 divided by 2 is 17. So I could also call that x is less than 17. My name is Sarah, so I'm going to call my age S. My son's name is Liam, so I'm going to call his age L. So if I'm translating this from words into equations, sum means I'm going to do an addition problem. So I'm going to be adding these two things, the sum of my age and my son. So that's going to be S plus L. That's the sum part. Now, I said before that is means that we're going to have an equal sign, but unfortunately, that wasn't quite as clear as it could have been. Because I really need to look at this whole thing together is no more than. Is no more than 64. So I'm going to put the 64 in. And I'm going to give you a second to make a guess of what inequality thing goes in here. You can just write it for yourself. You can just think it. You can trace it with your eraser really lightly so you don't have to erase something later. But just take 20 seconds to think about what's the symbol that I need to write in there. Typically, a word problem is not going to say the or equal to part. The word problem is going to use words, phrases to convey the or equal to part. Now, if I kept going with the sentence and I said like the sum of my age and my son's age is no more than 64. But no less than 50. So now that no less than piece means that. Now, I could also just sort of other phrases that go with that and would mean the same thing. On the no less than 50, I could say at least 50. And on the no more than phrase, I could also say at most 64. Are a couple of different ways that we can think about absolute value. So notation wise, we use 2 vertical bars. So if I had, I'm just going to put a couple of things in here, 2.3, absolute value of 0, absolute value of -4/3. What we usually think about, or the phrase that usually comes out when we say absolute value, is either that sometimes you hear, oh, you just get rid of the sign, or that it makes everything positive. It's pretty much fine to think about it that way. So the absolute value of -5 is 5. The absolute value of 2.3 is 2.3. The absolute value of 0 is 0. And the absolute value of -4/3 is 4/3. But here's really what's underlying that absolute value thing. Absolute value is a symbol that's talking about a distance on the number line. So when I think about that -5, that's really saying, what's the distance from -5 to 0? And that distance is 5. Right? If you, I don't know if anyone is from San Francisco. I actually don't know how many miles away San Francisco is. Just let's pretend it's 65 miles from here. So if I'm driving from Davis to San Francisco and I plug it into, oh wait, we can figure this out. We have the technology literally in our pockets to figure out how far San Francisco is. So I'm just going to throw this into Google really quick. I'm going to go to San Francisco. And Google's going to tell me that it's 74 miles away. That's the distance. Now, I'm going to flip that around and say we're going from San Francisco back to here. And you know what? It still tells me the same distance. Because when we talk about the distance between two places, we don't think about one of those directions as being negative 73 miles and one of those directions being positive 73 miles. So when we're talking about the distance on the number line, that distance is always going to be listed here as that positive number. Which is why if we think about absolute value as a distance on a number line, it's always going to spit a positive number out for us. So if we think about 2.3 on that number line, here's 0, here's 2.3. The distance between 0 and 2.3 is 2.3. There was nothing to do to it. I didn't have to make it positive or make it negative. Now, one of the reasons that I love to think about absolute value in this way is I actually think it makes the inequalities make more sense. So if I wrote something like the absolute value of, and I'm going to start with an equality and then we'll talk about an inequality in a second. But if I said the absolute value of x minus 4 is equal to 3, then what this means on the number line is I can read this part out as the distance between a number x and 4 is equal to 3. And if I draw this out on the number line, here's 4. And that tells me that if I move 3 away from the 4, so either I come over here or I go over there, but x lives in one of those two spots. So if I went 3 up from 4, I'd be at 7. And if I went down 3 from 4, I'd be at 1. So that means that x is equal to 1 or 7. Now, if I change that problem just ever so slightly, to say the absolute value of x minus 4 is less than 3, then again, I can get my number line going. Here's 4. And this is saying that the distance between x and 4 is something less than 3. And if I go out 3 in each direction again, I'm closer to 4 than being 3 away. So on any of these numbers in here, which means I can write that as saying x is greater than 1, but less than 7. Or if you like the interval notation stuff, I would write that as 1, 7. And it's in parentheses because we didn't have the or equal to part. I'm just going to keep throwing this in, but again, I'm not expecting you to use it unless you like it better. in which case that's fine. For completeness, might as well get the other one in here. And if I have the absolute value of x minus 4 is greater than 3, same number line. Here's 4. Gonna go 3 in either direction. But this is saying the distance between x and 4 is more than 3. So I'm more than 3 away from that 4. I'm out here on the edges. Now this one I think is a little bit messy to write, but it's not too terrible. So if I'm going to use the inequality notation, this says that x is less than 1 or x is greater than 7. If you wanted to do it in the inequality, I mean in the interval notation, because I'm going out to the edges of the graph, I need to grab that negative infinity, positive infinity thing. So I'm going to say negative infinity to 1 and 7 to infinity.